Hello and welcome to this episode of T-Tech. On today's episode, we're going to talk about virtualization basics. So we're going to cover lots of things. We're going to cover the main motivation and goal for why we use virtualization, as well as how it's implemented, and even how you can do it yourself. So the main idea, starting back years ago when we didn't have virtualization technologies, about 2004, the way we did everything was whatever problem we needed to solve, whether we have a client, a server, or the network, is we had an entirely dedicated computer for that task. So our clients, we had dedicated Windows, Mac, Linux, BSD machines, and they connected into the network that's made of a physical router, a physical switch, physical firewalls, and physical access points. So this is all physical and it's dedicated to one task. It's the same way with our servers. Our servers are dedicated to one task, and everything in it is one computer itself. So one set of hardware in all of those things. There isn't really any flexibility with a traditional infrastructure that uses dedicated hardware. So what do we do here? The reasons we should use virtualization are lower overall hardware cost. So your total cost of ownership would be lower because you have less hardware to buy to achieve the same thing in your network. And as well, though, there is a lot better options when using virtualization for server migration and scaling, as well as network migration and scaling. Now, what I mean is, if you want to move a server over to maybe a more powerful hardware platform, what happens without virtualization is you have to spend the money to buy an entire new platform. But as well, though, even for updates and upgrades, either in the network or the server space, if I want to upgrade the operating system or test a new feature of that system, I have to go ahead and find a new physical box to implement that on. With virtualization, you can really have advantage with deployment testing, where I can test things without breaking the existing production environment, where I don't have to take a physical box and put it in place. So because of that, though, you can easily take snapshots of your entire virtual machine, your VM, and you can back up data. So now that's really great for the enterprise type, business use case, but also for the business, and really what applies to you and me for the most case is that when you're using this, you can run multiple operating systems. So let's say you want to try out Linux. This is a great way to do it. You can make a VM with Linux inside of Windows, and you can mess around with it that way without doing something like a dual boot where you have a bigger risk of breaking your PC. Or even in the enterprise, you may have a certain application that only runs on Windows or Linux or something like that. But, this is how you would do that. Now, without virtualization, talking about more of the details of it, you have, in a normal computer, you have the hardware, you have the BIOS, you have the UEFI, depending on its age, the bootloader, the operating system, and the programs that the operating system is going to run. Now, the whole thing is you're locked into this unless you switch you could split it in half here at operating system and, bootloader, or even right down to the BIOS. And you want to put something new on there if you need something different or your needs change. That's where you have inflexibility without virtualization. But what we have is system virtualization. Now, we still have one computer, okay? And that one computer has all the things we talked about earlier. And it has hardware, and this is known as resources. And the job of how we do virtualization is actually with something called a hypervisor. And a hypervisor's job is to sit in between the real hardware of your computer. And basically, if you have a loaf of bread here, what the hypervisor is doing is it's taking a knife with the bread and is chopping your hardware up into partitions or sections. All right? So then what it gets when it does that is virtual sections of all your computer's resources. And what happens after that is the hardware of your virtual machine. And it still has its own BIOS because the software we're going to use, at least on a general purpose PC, and you'll see why I said that in a minute, is it has its own BIOS, excuse me. But then as well, it has all the normal things you would expect. It has a bootloader, the operating system, and programs. So what it can do is we have a full operating system. So VM1 could be Linux, and VM2 could be Windows. You could have a third VM that could be, Mac or, something like that as well. And what it does is it just gives the operating system and its programs a place to run the code. And it runs the same way, and it doesn't necessarily know it's even being virtualized. But this is called a Type 2 hypervisor, and the difference is very small of the differences of what they do. Type 2 is meant to be run on a general purpose computer. So that means your laptop or your desktop. But what we do is the Type 2 hypervisor is something like VirtualBox or VMware Player, and you install this on your operating system like Windows or Linux or Mac, and you can choose when you want to run virtual machines. But if you don't want to run virtual machines at that point in time and do something different, you can close the program. So the program runs on top of your operating system. Now that also means for performance-wise though, this is not as fast. And we're going to see an advantage of a way we can make it faster in a second. So, this is what you're going to see in production, in businesses, etc. And this is a lot of what the cloud really is you're going to have a lot of these Type 1 hypervisors and things of that nature in data centers. This is what the cloud is. So, what you have is this would be server hardware. It's still the same kind of hardware, just more reliable and faster, along with better performance. You have the real hardware, but instead of a Type 2 hypervisor that is a program that runs on your operating system, your existing computer, you have a Type 1. Now, the difference is the Type 2 is a program. It has an operating system that is allowing it to run. The Type 1 is, it includes an operating system inside of it, as well as the programs of the operating system that is going to slice up the resources like we talked about before, and it's going to run the VMs in the same way, and you can get all the benefits we talked about. The difference is this is faster and most times more reliable. But the disadvantage is if you did this on your laptop or desktop and you installed something like VMware ESXi or Proxmox or something like that, those are examples of this. The difference is you can only use it for virtualization, okay? You couldn't browse the web on it. You couldn't do video editing or graphics editing or anything like that. But the idea, though, is we still have full operating systems that are running because of the hypervisor. And they have a partition or slice of the hardware of your real computer. Now, the last type of virtualization that's important is application virtualization, and this is also referred to as containers. Now, this is in programs like Docker on Linux and things. What it does is up here, how we had we have the hardware and all of that, and an entire operating system, and then the programs. What we're doing now is we're stripping away these other four layers of it, and just virtualizing the programs. We're virtualizing the code itself. So we still have all the real hardware, and this could be on a server or on a general purpose computer. But on your operating system, you install Docker or something similar, and instead of virtualizing the hardware resources, since we're running an entire operating system and the OS's job is to manage these resources, the application isn't designed for that. It doesn't care about that. It only cares about being able to make a system call to the operating system, so then the operating system can make the hardware do something useful. So what we do is we can virtualize code like Apache or Postfix or MySQL, and you can even take the user land. So that just means the programs that an operating system allows to run, and you can run only that code instead of having to have an entire operating system to run each application. So these are things like virtualizing the system calls or driver interfaces, things like that. But that is application virtualization. And the advantage is, if we want to run, 50,000, 100,000 Apache web servers, what is better? Having the apps do it or having a hypervisor do it? Well, the hypervisor approach doesn't scale very well because you have to have enough resources at a minimum to allow the operating system to run, and then the operating system has to have enough resources to run the server with the amount of load you expect to have on that system. So in this case, we can just run a lot more apps instead of running the VMs to support that same situation. All right, so that is the basics of virtualization. Coming up in a second, we're going to have a quick little lab where I'm going to go and show how to download VirtualBox and how to install that. So I will see you there. Alright, so what we want to do is go to virtualbox.org in any web browser, and you want to go to download VirtualBox and then whatever version it is. So we're going to go ahead and click that. Now the platform packages is where you want to focus your attention, and these are all of the operating systems that VirtualBox can run on. And the extension pack, is important if you want better performance of different types of hardware, like your graphics cards or, as it says, USB 3.0 and things like that. But what we want to end up with here is clicking the Windows hosts. All right, we want to save that file. And once that's done, I'll be back with you. But basically, you just go to your downloads and go ahead and double click the file, and then we'll go through the installation. Okay, here is the installation. And what we want to do is go ahead and click next. And most of these options here, like the VirtualBox networking, the Python support, etc., you want to leave these enabled as they are. If you want to edit them, if you don't want USB support for some reason, you can just go ahead and unselect it. And it will just be installed in your program files as usual. You can browse if you want to put it somewhere else though. Now we're going to say next here. Keep all of these checked, and those will do fine for a basic installation. And this part here, the network interfaces warning, is because remember how I said it takes your resources and slices it up? Well, in order to slice up your network interface, your real network interface on your computer, it needs to install the interface and a driver for it to create a virtual interface. What this will do, though, is disconnect you. So it's just temporary. So we're going to go ahead and click next. Or yes, I mean. And then we want to go ahead and install this. We want to say yes to the dialog. I don't know if that picked up or not. And then you want to go ahead and just be patient, get a coffee, whatever, and let it finish installing. And at this point, you can just leave that checked, and we can go ahead and click finish. Okay, and you may see, I don't know if this is picking up, but you'll see a download button if a new version is out. Okay, that's how you get it installed though, and I'll see you in 1 second. Okay, so now we've opened VirtualBox, and what you want to do is click New here, and we're going to name this Test VM. And down here where it says Machine folder, this is where it's stored on your file system. Okay, in your users folder, your name, and in a folder called VirtualBox VMs. Now, the type is the type of operating system you can install in the VM. And if it's not listed here, you can click Other and try to still install it. With the type of operating system, in the version field, you can select the release of that operating system. So in this case, like with Windows XP, if you chose the 64-bit version, likewise with any of these versions, what would happen is the hypervisor, which is VirtualBox, would show the VM. Would show the operating system, a 64-bit CPU. And that means the kernel, so Windows XP's kernel has to be 64-bit to run on that CPU. So if you mix either the kernel or the version of the CPU you want to run on in the VM, it will not boot. So 32-bit can still boot on 64-bit, but 64-bit cannot boot on 32-bit. It just will not execute. But we'll show you in a second, if you make that mistake, that it's easy to fix. Okay, this is the RAM. The RAM you're going to give to the VM. Here we can give from 4 megabytes up to 8 gigabytes, I'm sorry. And we're going to give it 2 gigs here. And you want to click Next. As far as the virtual hard disk, the safest option to go with is create a virtual hard disk now. Okay? Sometimes you may not want to add one. That's in cases if you're booting over the network or anything non-standard like that where you wouldn't be using a hard drive. If you already have a hard drive, you can use an existing file. So this is a project I'm working on, and I have an existing file that I could add and associate with this VM. But the main thing is create a new one though. And this is the recommended size. We're going to click create. And this is what the format of the file will be. What you have to understand is the VM can only interact with data in this file. It cannot edit data on your actual computer outside of the file. So it can only delete files and make files in this file. Now normally I would recommend fixed size. And the reason is what happens with dynamically allocated is it will actually grow that virtual file. So where the VM will store its information, it grows the file up to a certain size if the operating system needs more hard drive space. Okay? So what that would mean is you could potentially run out of space on your real computer. So that's why I actually recommend fixed size. Okay? So after that though, just hit next. And this is where it's stored. Every VM has its own folder, and then that is the file. And the cool thing is you can manage it just like any file. Okay, you can rename it, which isn't recommended because then it wouldn't boot, but you can store them, rename them, copy them, paste them, etc. You can also have that over. You could put if you have like a NAS or something in your network, you could put the file on that NAS and then point, like you would use an existing hard disk, and then you could point that over a network share or anything like that. But for just starting out, you don't have to worry about that. This is to get the point across that it is a normal file. It can be sent over a network, etc. For time purposes, I'm going to make this 2 gigs. Now, I'm not going to install Windows in this case, but for now it's just 2 gigs. We're going to create. And again, if it was bigger, it would take a little bit longer. This depends on the speed of your machine. All right, when you have your VM highlighted in the left panel, the stuff in the right panel is a summary of all the important settings. Okay? And when it's highlighted, you can click Settings. And for now, we're going to ignore most of these settings for simplicity. And we're going to go to Storage. And what you want to worry about is this CD icon here. You want to click on that. This is where your ISO file will be selected. Okay? So this is like your ISO of Linux or Windows 10 or anything like that. What you do is you would just click this icon and then browse for that file. And once you put it in there, you'll just see the path to the file. The other thing you want to potentially change, not always, is the network adapters. Now, you don't have to worry about these other 3 unless you want to do something with firewalls in a VM or do something with servers. Don't worry about any other settings here. You can leave these how they are. And the only thing you potentially may have to do is if the operating system you're using doesn't have a driver for whatever network card is here, you may want to change the adapter type. Okay? Right here, it's an Intel Pro 1000 MT. If I didn't have a driver for that in Windows, etc., I could choose a different a different network card here. And the para-virtualized is for if the VM knows it's being virtualized. That's actually much quicker. But, excuse me. The only other thing about that is understand this is that virtual NIC. So you can control what the hypervisor presents to the VM. Okay? Other than that, if you made the mistake, how we said, about the 64-bit or 32, you can change that here. You can get back to the wizards menu right here. Okay? We're going to hit OK. And the last thing I want to show you is some stuff with the VM if we right click. So you can go to the settings from there and you can clone it as well. This is the snapshots we talked about, okay? You can start it, etc. Now the last thing I'm going to end on is if you go to File, you can export an appliance. So I could configure this how I want with Windows or whatever OS. And if I highlight it, I can export it as an appliance. That means I could send it to a friend or store it somewhere, etc. And what they would do when they get the file, it exports it to an OVF file, Open Virtualization Format. And what they would do is import it. And when they import it, they get a snapshot of our entire operating system and its settings. So that is a little bit about virtualization and a little bit about how to set it up for yourself. I hope it was helpful and I hope it wasn't confusing. But as always, I'm Tyler with T-Tech. Hope you enjoyed the video. Have a very nice day.